Tornadoes. They are known as nature's most violent storms. And kind of the reason that they have that moniker is because they can have some of the strongest winds on Earth. Hurricanes can come close, especially a Category 5 hurricane right in that eye wall where we get some of the strongest winds. But tornadoes can have winds over 300 miles per hour. There aren't a lot of records of that exact reading because, of course, we can't necessarily collect data inside every tornado. A lot of storm chasers do try to get sensors and anemometers to figure out how strong the winds are in tornadoes. But generally speaking, we never get data from the majority of tornadoes that touch down. So as we'll talk about, we use different ways to figure out the storm's speed. But generally speaking, in the real big, the monster tornadoes, the very strong tornadoes, you could be talking upwards of 300 mile per hour winds. And I know that's kind of hard to understand, 300 miles an hour, but when I'm driving on the interstate or on the highway, I'm maybe going like 70, maybe 80 if I'm pushing it. So that kind of gives you an idea. And if you were to open the window when you're going 80 miles per hour on the highway and, you stick your hand out, your hand actually, gets blown back, and that's 80 miles per hour. So you can only imagine what 300 mile per hour winds are capable of doing. So, just a quick overview of if this is your first time watching. I think it's always important to just kind of give you my background a little bit. I'm a meteorologist at WMUR TV. Meteorologists are people who study the weather. So it's not just people who work on TV. There are lots of different meteorologists doing all sorts of different things. Maybe they're storm chasers, or maybe they're out and they're collecting data about flooding and other different types of weather phenomenon. So meteorologists are generally people who study the weather, and my job is to study the weather, predict the weather, figure out what it's going to do over the next, say, 7 days, and then present that on TV. All right, so what is a tornado? Well, I thought this was a really cool picture. We call this type of tornado a rope tornado, and I don't think you have to guess why, right? It kind of looks like a rope, doesn't it? A tornado is a narrow, violently rotating column of air that extends from the base of a thunderstorm to the ground. And typically wind is invisible. And remember, a tornado really is just wind, which is always hard for me to sort of wrap my mind around, but it is just wind. And the reason that we can see the wind in the form of this cone, or in this case, a rope tornado, is because it's picking up dust and debris along the way. So that's why, and what's really cool about this picture is you can really see the dust and dirt getting picked up down here. And how do tornadoes form? Well, we need a few, I like to call it a recipe, but you need a few things to all come together in the right way for tornadoes to form. Essentially, tornadoes form when you have a thunderstorm. So how do we get a thunderstorm? This is the way I like to think about it. So we have warm air and we have cold air, and they are meeting up along a boundary. We call that a front. And a lot of times tornadoes forms along fronts, particularly cold fronts. And when you have warm air and cold air meeting up, they don't like each other. And the warm air is forced to rise, and it goes up. And it creates that big towering cumulonimbus cloud, or even a supercell. And what happens is, as that warm air is going up, it actually allows access to some much stronger winds in the upper part of the atmosphere. And we can tap into some of those strong winds, and instead of moving in the horizontal as they typically do, they're forced to go in the vertical. And so that's how the tornado forms. That's where we're getting that wind from. But in order to even have all of that happen, you need ample moisture, you need some instability, and you need a lifting mechanism. And a lifting mechanism is that front I was talking about. So the lifting is literally that warm air being forced to go up. And the moisture, of course, is very moist air. So typically we see tornadoes on days where it's pretty humid. Maybe it's been hot. though there can be times where we have tornadoes and it isn't that way. There's always exceptions to the rules in meteorology, but those are typically the main three things that you need to form a tornado. So how about, where do tornadoes occur? This is always a stat that kind of boggles my mind. Tornadoes have occurred in every state in the United States. So yes, even Alaska, even Hawaii, even in places that you would never think, maybe you're from Oklahoma, like one of those students are, and you're like, wow, they get tornadoes in Maine, and yes, they do. And where I am in New Hampshire, we do typically get tornadoes, at least 1 to 2 per calendar year. But the map that you see here, this shows you where, I know it's a little bit hard to see, but that shows you where tornadoes are most typical in the United States. So it is mainly through that central part of the United States in the plains. This is an area that we call Tornado Alley. That's the nickname for it. And one thing to note too, as climate change is becoming something that we're learning more about and seeing more, we are seeing that there are more tornadoes that are occurring outside of Tornado Alley, and in particular in the southeastern U.S. So in places like Georgia, Alabama, Mississippi, Tennessee, of course, with last month's or earlier this month's deadly tornadoes that move through. So we're seeing sort of a widening of Tornado Alley. And the problem with that is a lot of those states and communities aren't as prepared maybe as some of the plain states. So we're seeing a lot more issues with even home construction not being as strong in those areas, because maybe they just weren't thinking that tornadoes were as prone, they weren't prone to as many tornadoes there as they are now seeing. So that's one of the ongoing areas of research, actually, where they're figuring out why tornadoes are happening more in the southeastern U.S. and how to better protect people there. Now, since I'm in New Hampshire, I figured we do have to talk a little bit about New Hampshire tornadoes, and here are some fast facts. Now, on this map here, you can see all those little flags, and those are the tornadoes that have occurred in New Hampshire in the last 50 years. So there has been a lot. It is primarily in central and southern New Hampshire, though there are some in the northern part of the state. But typically, our tornadoes here in New Hampshire are pretty weak. And we'll talk about the EF scale, but it goes from 0 to 5, with 0 being the weakest to 5 being the strongest. And typically in New Hampshire, our tornadoes are 0s or 1s. So not super strong, but still can cause some damage. The strongest tornadoes in the state have been EF3, so we've never had an EF4 or 5. And New Hampshire actually has the longest tornado track in New England. And that storm was on July 24th, 2008, and it was 50 miles long. And I'll show you that here. This is a map of it. I know that's kind of hard to see, but it moved from just near the state capital, Concord, up by Lake Winnipesaukee. You can see some of the damage in these photos. And what was remarkable about this storm is the damage. I mean, this house here, this looks like the damage like what we saw recently in Nashville, and places where tornadoes certainly happen a bit more frequently. So it was really remarkable to see that type of damage here in New Hampshire. So let's talk a little bit about damage. So how are tornadoes, how is the strength or that EF scale determined? As I mentioned, we can't measure winds in tornadoes because we simply don't want to be near tornadoes. Even storm chasers, if they're out and they're trying to collect wind data, sometimes they're trying to put these anemometers in the path of tornadoes, but a lot of times they miss them, and so it's much more rare to actually get data than we would ever get. Most of the time, we're not getting data from the tornadoes themselves. So what we are doing is, after a tornado touches down, a team of meteorologists from the National Weather Service goes out and they survey the damage. So they go out and they analyze it and they look at what was damaged and how it was damaged. And that's how they make their determination as to how strong the winds were. So, for example, in these pictures here, an EF0 has winds between 65 to 85 miles per hour, and maybe there's a few trees down, or there's a few shingles on roof that was brought down, or smaller structures that were not as sturdy had damage. That's what the meteorologist would be looking for. But then when you get up to like EF1, that's when you can have winds up to 110 miles per hour. And that's when you start to see maybe some windows are broken, bigger trees are coming down. And then as you work your way up, EF2 has 135 mile per hour winds. That's when you're starting to see bigger areas of roof covering taken off, bigger trees. And then all the way up to the EF5, which is over 200 mile per hour winds. And that's when, in that picture there, all you see is the foundation. Like literally the homes, and particularly brick homes, are literally just completely blown away. So that's how meteorologists know that storm had 200 mile per hour winds. So when you hear us meteorologists talking about the EF scale, that's what we're talking about here, the estimated wind speeds based on the damage from 0 to 5. And maybe some of you are saying, what is EF? Well, EF stands for Enhanced Fujita. And Fujita was a scientist meteorologist who made the Fujita scale and studied tornado damage and made this scale. And then probably about 10, 15 years ago, with new studies coming out about the damage, they changed the name to the Enhanced Fujita scale, so the EF. So it means Enhanced Fujita, and it goes from 0 to 5. All right, so I love this photo because I think it shows us a lot and it tells you a lot about what tornadoes can do. So what you're looking at there is a metal grill. So like you go out and you do grilling maybe on your back deck and you have a hot dog or a hamburger. Well, that metal grill, as you see there, not only was lifted off of the deck, but it was thrown into a healthy tree. Think about the power and the strength of those winds to not just lift that grill, but to throw it into a tree. It really is insane to think about that's even possible. But it did. And unfortunately, that's one of the main problems with tornadoes. It's not what maybe you would think about in the movies where people are getting like sucked up into the tornado. It's more the flying debris. I just recently saw a video. I wish I could find it, but a quick search on YouTube, you might be able to find it. But one of the tornadoes that have touched down recently, I believe it was in Texas, there's video of this car that, I've got like my daughter's toys over here. So we'll pretend I've got this car here. The video literally has a real car, and it was going like this and just rolling and moving along, all because of the wind. And it's just amazing to think that, a car, which I know this is a toy car, but a heavy car, could be thrown like a toy and just moved around like that. So, wind speed and it's just incredible what these tornadoes can do. And that's why the flying debris is actually more of a problem for people than the getting sucked up by the tornado. Unfortunately, that's how most people get injured or even die from tornadoes. It's from the flying debris. So let's talk a little bit about cars and warnings. Where should you go if a tornado hits? Well, these pictures will tell you that it is not safe to be in a car. So this picture here is actually of a pickup truck. Imagine if you were in that. You don't want to imagine that. I mean, that car literally looks mangled by the wind and the debris that hit it. And then this picture here is of a mobile home or a camper. Also not a place to be during a tornado because it's not, it doesn't have a foundation and it's not underground, quite frankly. In some of these really strong tornadoes, you simply have to be underground. So, what do we do when there is a tornado warning, and where do we go when there's a tornado warning? So, what do we do when there's a tornado warning? So, a tornado warning means that a tornado has been spotted by a trained spotter, or it has been indicated on radar. So you have to assume that if you are getting a warning on your phone, I know nowadays it's very common to get the warning on your phone, that as soon as you get that warning, you have to think that there is a tornado on the ground. It's not the type of thing where we go over to the window and we're looking for it. It's the type of thing where you have to take action. So then what is that action? Well, the best thing to do is to get to your basement, if you have a basement, or to the most interior room in your home. So interior, that means a room that hopefully doesn't have any windows. Essentially what you want to do is you want to put as many walls between you and the outside. So I'm pretending this is a wall. And we'll pretend that this pen is the tornado. So if you can put as many walls between you and the tornado or debris hitting that wall, that will protect you much better than being closer to a window. So maybe a pantry, a closet, a bathroom, hopefully that doesn't have windows. Those are good places to go, a hallway, if you don't have a basement. Now, what about a car? Is a car a safe place to be? Well, we kind of answered that. The answer is no. And you don't want to try to drive away from a tornado because maybe where you are, other people are doing that and there ends up being traffic and you get stuck in traffic with a tornado bearing down. Or you're on roads where it's raining and the roads get washed out. Or you don't know which way the tornado's heading and you could be heading closer to it when you're driving. So there's a lot of reasons actually that we really don't recommend people be in their car or try to outrun the tornado. So the safest place to be is in your house, in the basement, or in an interior room. That's the best place to be. Another thing that I've heard recently that would be a good reminder too is if you have a bicycle helmet or a motorcycle helmet, if you can remember to grab that and put it on when you're in the basement, that is actually really good. And that has shown to help people survive in some of the worst tornadoes. You've got to protect your body from the flying debris. All right, so that is a wrap on what I had planned to talk about. I wanted to show you this video because I think it really is telling. So this is the El Reno tornado. And I show this one a lot because to me this is like the baddest of the bad and the most just sobering look at a tornado. So in that video there, you're looking at the tornado. It's that big right there. We call that a wedge tornado because it literally just looks like a wedge of cloud on the ground. The El Reno tornado in Oklahoma happened in 2013, and it's one of the largest tornadoes on record at almost 2 miles wide during its strongest. It also injured and I believe killed a few storm chasers. So unfortunately this tornado is known very well, but for me, I like to watch this video and just see the incredible size of that tornado. I mean, it's just massive. The worst of the worst, really. And this storm chaser tries to get like really close to it, which is kind of scary. And, storm chasing, while it's really fun and some people are doing it for the right reasons, it can also be very, very dangerous. I mean, look at this video here. Wow. So you can see kind of the edge of it here, and you can see it spinning, the flow of it there. It really is incredible to see these tornadoes here. All right, so while we're kind of enjoying that and watching it, I'm going to get to some of your questions here. And And let me see what we've got. Okay, so Lisa, thank you very much for chiming in. Ronnie saying good morning from Nashua. Hi to Anne from Conway. Judy asking, have I seen Twister the movie? Of course. I don't think any meteorologist hasn't seen that movie. I'm actually like a super geek and I know a lot of the lines to the movie. When I was in college, all right, so this will be kind of funny, but when I was in college, we would have parties where we would watch Twister and people would recite the lines to it. Yeah, we're kind of weather geeks, but we're proud weather geeks. Faith, hi from the Lakes region. Karen, hi to Judy. Judy was asking, has there been a tornado in New Hampshire? Absolutely. We talked a little bit about that. Yeah, some of you are saying I've been freezing a little bit. The connection is a little bit tough from home here, so I'm sorry. Bear with me there. Yep, Karen is saying Elias is watching from Ackworth where a tornado came through. Yeah, it's pretty crazy. Let's see. Any other questions? Robert asks, is there always a thunderstorm? And the answer is yes. Tornadoes form out of thunderstorms. That's the parent, you could say. And there isn't always lightning necessarily, though I'd say the majority of them do have lightning with them. Sometimes there can be a lot of lightning, and sometimes there can be just a little. And Mary Ellen saying hi from Epsom. Looking for some questions. A lot of you just saying hello, and that's what's awesome. Excellent. Well, if you do have questions, Cynthia saying we don't live near El Reno. That tornado is bad. That's good. I'm glad you don't live near there in Oklahoma. It was a scary one. If you do have questions, I would love to answer them. So feel free to post them if you're watching this after, or you can send me an email, hlapointe@hearst.com. Thank you so much for watching, and I hope you have a great rest of your day.